Measuring segments. There are two main ideas that we discuss when we're talking about measuring segments. The first is the segment addition postulate. The segment addition postulate says that if you have a segment from A to C and you have some B that is in between that on the line, then the segment addition postulate says that A, B, that length right there, plus the length from B to C is going to equal the length from A to C, the entire length here. So that's really what the segment addition postulate is saying. Now, the idea of segment bisector is a little different. That says if you have a segment X to Y, and you have some point in between, we'll call that M, that cuts it so that the X to the M and the M to the Y is exactly the same, then that is what a segment bisector is. So in this case, the length XM is equal to the length YM. And another way to look at it is, as the segment addition postulate, XM plus YM is going to be equal to XY. It's the same idea as the segment addition postulate. You just have to note that these two segments are the same. So you might only be given one of them, and then you just have to double the other segment. So 2 of X times M would equal XY. Or 2 of Y times M would equal XY. These are just different ways that we can use the idea of segment bisectors and the idea of segment addition postulate. So for an example here, we're going to use the segment addition postulate, and we have the segment CX, and that equals 2x plus 3, XB equals 4x minus 1, and CB equals 17. We want to find the length of CX. So sometimes it's helpful to put in what you know, 2x plus 3, and 4x minus 1, and the entire length here is 17. So what are we going to do? Small segment plus small segment equals big segment. CX plus XB equals the whole segment CB. So that would be 2x plus 3 plus XB is 4x minus 1 equals CB, which is 17. Now we're just going to simplify, put our x's together. That would be a 6x. And then we put our constant terms together. 3 minus 1 is a positive 2. Equals 17. And then we're going to subtract the 2. And we have 15 equals 6x. And we have to solve for x, so divide by 6. And x equals 2.5. All right, so that's our x, but that did not answer our question because our question was asking us to find CX. So that is now what I have to do. So I'm going to take my x and put it in for the x in CX. So CX equals 2 times 2.5 plus 3. And then you can type that into the calculator. And you get 8. So CX is equal to 8. And that's it. For this next example, we're going to work on the segment bisector idea. Suppose AB bisects CD at point M. So let's draw that. The segment AB is bisecting CD So AB is cutting CD to make them exactly the same at midpoint M. So that's what our picture looks like, kind of. And now we know that CM is 2x plus 1. And we know that CD is 6x. So from C all the way to D is 6x. So what does this mean? This means that the MD is also 2x plus 1. So we can use the idea of segment addition where we add those two together, or use the idea of bisector and just double it. So 2 of 2x plus 1 has to be equal to the entire segment of 6x. So that would be 4x plus 2 has to equal 6x. Subtract the 4x. And we get 2 is equal to 2x. So x equals 1. But that's not what the question is asking. The question is asking us to find dm. So this length right here. So you take that 1 and you put it in for the x. So 2 times 1 is added to 1. And dm is going to equal 2 plus 1, which is 3. And that would be your final answer. So that is it for a video on measuring segments. We went over the segment addition postulate and the definition of segment bisector and how we use those in problems. Should be ready to take your quiz now.